Hello there, this is Professor Iris Miano giving you your Week 2, Day 3 lecture on Section 2.4. This is for Plane Geometry, Math 32 at Santa Monica College, and the section is about arguments. Now, I know what you might be thinking. Are we going to be talking about disagreements? Are we going to talk about the thing that you get into with your sister when she borrows your hairbrush without asking? No, these are not those kinds of arguments. Technically, the argument that we'll be referring to is a collection of statements. I mean, it's pretty bland definition here, but that is the extent of how we will be dealing with this topic here. Okay, so there's a place, if you're using the lecture notes that I provide for you to write this definition down. An argument is a collection of statements. That's what I want you to write down, just that phrasing. And these collections of statements have different categorizations depending on where they come in the flow of the argument. So the first set of statements are called premises. That's another thing you want to write down. Or premises. There's no wrong way to pronounce that word. You could either say premises or premises. And there can be two or more premises in an argument. And then the last statement is always the conclusion, and it usually is preceded by the word therefore. Now here, as you can see in this example, is a symbolically represented argument in which we have the first premise on the first line, which happens to be a conditional statement with two statement components, P and Q. P being the antecedent and Q being the consequent, just as a segue into a bit of review about this symbolic compound statement here. The second premise is just statement component P, and then symbolically, when you write down an argument, you traditionally put a horizontal line between the premises and the concluding statement, which in this case is statement component Q, and it is preceded by this triple dot, which is mathematical shorthand for the term therefore. And when you see arguments written out in English, usually, but not always, the last concluding statement is preceded by the word therefore. Okay? Now, how do you know when an argument is valid? And that's going to be a categorization that we're going to be getting into in this section, is being able to definitively determine if an argument is valid or invalid. So a valid argument has the characteristic that its conclusion is true whenever all of the premises are assumed to be true. So this can be kind of tricky to spot. So we're going to go over several examples over the course of this lecture, analyzing the truth values of individual statements within an argument, and using that to determine if the argument is valid or invalid. And the organizational mechanism that we're going to use for that overwhelmingly will be the truth table, although there are going to be some famous valid and invalid arguments that we will want to get to know, so that we can identify right away by structure in certain cases whether an argument is valid or invalid. So let me just give you a kind of a brief overview, and also in your lecture notes there is a place for you to fill in the blank in regard to this statement right here. In the middle of the page it says an argument is valid if, and then I wanted you to write down the conclusion is true whenever all the premises are assumed to be true. That's the working definition that we're going to use for a valid argument. So let's just say that we have that first example illustrated argument, and we want to see if it's valid or not. So again, recognize that we have this organization of the top row of this argument is the first premise, the second row is the second premise, and the third row underneath the horizontal line is the conclusion, the concluding statement. So when the argument is valid, then that means that the conclusion is true whenever the first and second premise are assumed to be true. So if we assume the first and the second premises are true, is the conclusion necessarily true? If the answer is yes, then we have a valid argument. If there's any instance in which the premises are true, but in that same case the conclusion is false, then the argument is invalid. It doesn't matter if it also has a case in which the premises are true and the conclusion is true. Okay? So it's kind of like when you have in your argument an instance in which premises are true but conclusions false, it's kind of like fly in the punch bowl. It just ruins the whole thing, and it doesn't matter that the punch was delicious to begin with, right? Like it just completely ruins it. So let me get a little bit more detailed about what I mean by that. So this is a breakdown of the truth value conclusions that we're striving to find if we want to definitively say that this argument's valid. That means first premise is true, second premise is true. We're assuming that. We're going to look at that particular case. If or cases, there might be more than one case in which both premises are true, then is the concluding statement also true in that instance. So we want to look at these three cases, okay? Because if you recall, because of the nature of the first premise being conditional, the cases in which the conditional statement is true is when antecedent and consequent are both true. Antecedent is false but consequent is true, or antecedent is false and consequent is false. Do you guys remember that? The only time the conditional statement was false, if you recall, is when you had a true antecedent and a false consequent. So that's the only case we're not entertaining here. Now, if the P's and Q's truth values are all known here, then we know what the second premise's truth value is going to be. In the first case, it's going to be true, and then in the second case it's going to be false and false. So really right away this case and this case is automatically disqualified, but let's, for the sake of completeness, just go ahead and put the Q truth values down here. Like I said, these two are not even being considered in the process of determining if this argument is valid. So we just have one case in all of the possibilities in which the first premise is true and the second premise is true. We just have the one case, and in that one case, the conclusion happens to be true as well. So, right, it seems like it's a valid argument. But if we want to be certain that we're entertaining all the different possibilities and we're being very systematic in our process here, we use a truth table to help us organize the information and ensure that we are investigating all of the cases. So, I believe we have exhausted everything on that first page of our lecture notes. So let's go ahead and continue with a specific example, our very first complete truth table example of analyzing if an argument is valid or valid on the next page. Okay, so go ahead and flip to the next page. And here I am showing you this argument that we're about to use a truth table to determine if it's valid or invalid. So here's how you would do it. So you will organize your truth table in a very familiar way, and it's already provided for you, so go ahead and just fill out the table along with me. You may notice that there's a few things on the screen that are in the truth table, I'm getting ahead of myself, that you do not see on your lecture notes yet. So I want you to first fill out your P and your Q columns in the standard way, because you'll notice over the entire course of the argument here, there's only two letters being used, P and Q. So that means that there's only two statement components in this entire argument. So that tells you that you're only going to have two initial columns, one for P and one for Q, in that order from left to right. Remember, because we go into alphabetical order with the letters that we choose. And furthermore, the truth value combinations are initialized in the standard way already given to you. That has never changed and will never change. From there, you make subsequent columns for every single premise and the conclusion statements. So notice that the first premise has a little bit of space underneath it in your lecture notes. So I want you to write there tilde P and Q, right? Or tilde P, P, conjoined with Q, okay? And we're gonna go ahead and analyze what the truth value of that compound statement is in a little bit. In the second premise area, the second premise column, I want you to put tilde P, because that's the second premise, right? That's the second line in the argument in its symbolic form that you see where my mouse is hovering, okay? And then the last column is going to be dedicated to the conclusion, which in this case is the Q. Now, remember, the triple dot is just there as a mathematical shorthand for the word therefore. Okay, so now I believe we're ready to write down our truth table, our truth value combinations for each of the premise, the first premise, second premise, and the conclusion. So this first premise is a compound statement with two connectives involved. So it might require a little bit of side work, okay? But ultimately what we want to put in this truth table is just the final answer truth values, okay? So that'll be this right here. So if you negate P and conjoin it with Q, remember all of those rules, you should get FFTF, in that order from top to bottom as your final answer. And if you don't, this could be a thing that we could talk about in class, okay? Secondly, for the second premise, you want to just negate P, which is super straightforward, hopefully. Everyone can follow that, where you just take the truth values for P and you simply negate them. You put the opposite. So in P being TTFF from top to bottom, negation of P will be FFTT. And then just simply copy and paste Q, which is TFTF. Okay, here, now that our truth table is completely filled out, this next stage is the analysis. And the analysis is as follows. You want to look at all of your premise columns, which I am pointing at in blue right here. Okay, you have a first premise and a second premise. For longer arguments, you might have a third premise or a fourth premise. Okay, it's all of the statements that are above the vertical line in the symbolic, argument configuration, or everything that's not the concluding statement. Those are all premises, okay? So you want to look for the row or rows in which all the premises are true, all two of them, okay? So you're basically looking for the rows that have a T here and a T here. Look, there's actually only one row in which that happens. So you want to either figuratively or literally in your work circle that row and include the conclusion. Now, you're not necessarily focusing on the conclusion just yet. You just want to capture all of the rows that have true premises all the way, which is this one, true and true. Notice that all of the other cases, they're either both false premises or one of them's false. You can't have those be in consideration in regard to the analysis of determining if your argument's valid. You're only looking for true premises. Now, this case where the premises are true happens to have a true conclusion. Is there any instance in which there's true premises but a false conclusion? So this is where I'm asking right now, any false conclusions? Well, no. Among the cases that I circled here, which are the only ones being recognized in consideration for the analysis on whether the argument is valid, okay? So this means that the argument is valid. I know, it might seem a little bit anticlimactic. Oh, sorry, go ahead, go back there. With this particular example, but we're going to have more examples of this. So the more examples you see, I think the easier it'll be to determine, what's going on here with this process. It'll be a little bit easier to flow with it, okay? So that's the first example. Let's go ahead and dive into yet another example, and this one's going to be extra fun because the symbolic representation is not given to us. This argument is written in English, but do notice that for components there are letters and connectives that are being given to us, okay? Some of the components are given to us, and it's our job to just use those already established letters if they're given. And also, you'll notice with the second part of this conditional statement in the first premise, there's also a negation keyword that's used, and so that has been absorbed in the symbology here for the consequent. Okay, but let's just go ahead and read the argument together in its entirety. I'll read it out loud, and then we will together translate it into its symbolic form. Then we're going to bust out the truth table for it to determine if it's valid or invalid. Okay, starting off with just reading the argument, we have if the winds are from the east, which we'll use the letter E for, then we will not have a big surf. So that's coming at us in the form of tilde s. So that means the statement component we will have a big surf is simply just an s, but since there is the presence of this not negation connective right here, the word not, that means that the symbol s has to have a tilde in front of it. So hopefully that's very straightforward and people can feel good about that usage. That was the first premise. It was a conditional statement, and it's going to go E, arrow, tilde S. Okay, we'll get to that in a second. The second premise is we do not have big surf. So you can probably, in your mind's eye, determine how that should be translated into symbolic form. We're going to do it together in just a second. And then the last sentence is predicated by the word therefore, so that should key you into the fact that this is the conclusion, the concluding statement. And it is therefore the winds are from the east. Okay, so that was already established as a statement component using the letter E. So this is therefore the symbolic translation of the following argument. Okay, so first give yourself this horizontal line and a triple dot, right? So we're going to put all of our premises up top in order that they come. So first premise goes here, second premise goes here. We actually have to have two premises here. So then the third sentence or the concluding sentence will go here after the triple dot. And it translates as such. The first sentence is conditional by use of this if-then connective. E was established as the letter associated with the antecedent. And the consequent was also represented by tilde s, incorporating this not usage, the negation connective. Okay? So hopefully this translation of the first sentence and this representation here is terribly straightforward. Okay, how do we translate the second sentence, aka the second premise? We do not have big surf. Well, that's tilde s, right? Okay, and the last sentence, therefore the winds are from the east. Go ahead and represent that with the letter E alone. Will be appropriate there. Okay, now let's go ahead and bust this into the truth table that I've already established for you. Remember to establish E and S truth values in the standard way. And in the title cells, make sure you write the first premise. E implies tilde s in the first premise area. Second premise is tilde s. Conclusion is E. Go ahead and add those specific statements in their symbolic form yourself. And then if you need a little bit of side work to figure out what the conclusionary truth value is for each case of this conditional statement, by all means do a little bit of side work. But here I'm going to show you the final answers. So here's the truth value combination for E implies tilde s. You should have false, true, true, true in that order from top to bottom. Tilde s is just negate the s column, and E is just copy and paste. Okay. So now we're going to analyze this argument to see if it's valid or invalid. So first step, look at your first premise and second premise. Look for the rows in which they are true at the same time. So you're looking at TT and TT. It looks like it's the second and fourth rows underneath the title row. Okay, so I'm going to go ahead and circle the first, second premise and conclusion values of each of those cases. Okay, now that you have the cases highlighted that you want to look at, we're not going to look at the first row and the third row. Why? Because they have false premises. We don't care about those cases. We only want to care and focus on the cases in which both premises are true at the same time. Then, next step, you focus on the conclusions. Are the conclusions true? Well, there's one case in which the conclusion's true. Any false conclusions? By that, I mean among the two cases that we've circled, which help us analyze if this argument's valid or invalid, are there any instances in which the conclusion is false? Yes, or I say yep in the PowerPoint here. This means that the argument is invalid. Okay? Fly in the punch bowl right here. It doesn't matter that this case exists, okay? True, true, true. Yeah, it would be great if that was the only instance in which the premises were true, but we have a case in which the premises are true, but the conclusion is false. That is an invalid argument in a symbolic format. Okay? Cool. Hopefully that makes sense. We have more examples coming, but at this time, I want to introduce to you what I like to refer to as the celebrities of the argument world. So these are the famous valid argument structures, okay? So if you see these particular structures, and they have fun Harry Potter-like names, modus ponens, modus tollens, law of syllogism, and disjunctive syllogism, right? So if you see this structure in some arguments that you are coming across in your homework exercises, or if you get really like super nerdy with this stuff, and you feel like structuring arguments symbolically that you read like in real life, then you can determine their validity this way, which I think can be a very interesting exercise, an extracurricular exercise, that is. Okay, so anyway, what are these arguments like? Why do we feel like they're valid? Well, you can always bust out a truth table on any of these four arguments, and they're going to be valid arguments. You'll be able to analyze them and get to it. Get to that conclusion. We might want to, though, kind of, what's the word I'm looking for? Talk our way through why we think these particular arguments should be working out for us. Well, take a look at modus ponens real quick. So this argument basically says, okay, if I have a conditional statement that I know is true, so that means I started off with P and I should end up with Q. Well, then it's just kind of like a rehashing, right? This second premise of P and conclusion statement, like following with a Q, that's just more or less a rehash of the conditional statement itself, right? It's saying that the conditional statement happened, so therefore I started off the conditional scenario, and I ended up with what I thought I should end up with. So modus ponens, it's like the conditional statement reaffirmed. Modus tollens, on the other hand, I like to think of it as connecting conditional statements to their contrapositives. You guys remember the contrapositives being the flip and reverse, right? The flip being the switching of the consequent and the antecedent. So the P and the Q switched places, and then they both got negated. Yes. So logically equivalent, the conditional statement and its contrapositive are. That's been presented already in the previous section. So modus tollens is like, okay, I'm going to initialize a conditional statement, and then combining the initialization of the negation of the consequent, and then assuming that the negation of the antecedent should follow, is more or less a implementation of the contrapositive. So it's like the contrapositive being recognized as logically equivalent to a conditional statement. That's what makes modus tollens work. Law of syllogism. This one's interesting because it takes into account a mechanism that hasn't, been introduced in this course yet, but is coming up, which is basically like, what is that called now? It is escaping me what that is called. It's if you assume A to be true, and then or if A is equal to B and B is equal to C, then A is equal to C. It's the transitive property. We'll get into that a little bit later on. We'll get into later chapters. So this is saying you start off with P, and you should be able to conclude from there that Q is going to happen. Then pick up where you left off, start off with Q, and then and then R is supposed to follow from Q. Well, cut out the middleman of Q, and you should be able to go straight from P to R. So anyway, the law of syllogism is basically a logical illustration of the transitive property. Lastly, we have the disjunctive syllogism, which is to say if you have P or Q happening, right? If that means one of them has to be true. And if the negation of P is true, then that means the original P has to be false. So the only other way that this disjunction right here will be true is if Q is true. So then it's be true here, via the mechanism by virtue that original P has to be false. So it's P is false, Q is true, makes this true. The falseness of P being negated makes the second premise true, and so therefore the only way the disjunction in the first premise could be true in that case would be if Q was true. Okay, anyway, so I'm not sure if any of that was helpful. Most importantly with this is to get to know, I hate to say the word memorize, I'd rather say internalize. Go ahead and internalize these four structures, and then you'll be doing yourself right to prepare for the upcoming exam. Okay, exam 1 is going to have an opportunity for you to use these standard forms for valid arguments in order to do a little bit of a shortcut on at least one of the exercises. Hint, hint, hint. So just like there are the good guys, right, in our stories and or celebrities that are generally associated with good guy roles, there's also the villains, right? Okay, so these are the famous fallacies or standard forms for invalid arguments. And they are the fallacy of the converse and the fallacy of the inverse. And their basic story is, with the fallacy of the converse, we could start there, which is to say, if you are assuming a conditional statement, you cannot assume that the converse is also true or logically equivalent. And the same is true with a conditional statement and its inverse. So hopefully that's enough, like saying that is enough to kind of explain how these two arguments are indeed invalid. And if you're not convinced, you could always place them in a truth table, and you will be able to conduct the analysis that's already been outlined to convince yourself that indeed they are invalid arguments. They will, in the truth table, display at least one case in which the premises are true, but the conclusion is false. All right, let's go into another example here. And in this example, we have a argument that's presented in an English language format. And what we're going to do is we're going to use the standard forms that we see at the top of this page to determine if the symbolic version of the argument that we're going to create ourselves is either valid or invalid. We'll be able to identify the structure by inspection. Or rather, that is the what's the word I'm looking for? The purpose of this exercise. Okay, excuse me. Let's start by translating this argument into symbolic form. So notice that they don't give us any letters to work with as far as taking the components and translating them into symbols. So what we're going to do is we're going to make up our own. So let's focus on this first premise, aka the first sentence, first statement. If I go to college, then I will not be able to work for my dad. So I've decided to say that I go to college is represented by this the letter C. That's going to be the statement component for the antecedent. The consequent is I will not be able to work for my dad, recognizing that the not negation connective of not is in play. I'm going to have a tilde in there, and I'm going to say D for dad is going to represent the consequent original component. The original component D alone would read as I will be able to work for my dad, but since there's this not word, we need the tilde. Okay. Then from there, I will translate the second statement into tilde C because it reads I did not go to college, right? So that's no on the college. And then the final statement, so, bust out a horizontal line and a triple dot indicating the word therefore, I went to work for my dad. Now that's just going to be a standalone D, okay? So looking at this structure here, do any of the standard valid argument forms or standard invalid argument forms match this particular argument? So we have a conditional statement. It looks like we negated the antecedent as the second premise, and then we negated the consequent as the conclusion. I know, you might be thinking to yourself, I negated a negation of D? Yes. Negations work in logic the same way that negative signs work in algebra. When two of them come together, they cancel each other out. Okay, so the negation of D, therefore, is just D. So does that match any structure that we see in either the valid or invalid arguments? It does. It's exactly like fallacy of the inverse, okay? So the conditional statement is established in the first premise. We negate the antecedent. And if we assume the negation of the consequent, that is an invalid argument and it's fallacy of the inverse. So therefore it's invalid. I'm going to stamp it with an invalid on there just for fun. Big old red stamp. Okay, so hopefully that made sense. And if it didn't, we could talk about it more in class. Let's bust out another argument. This one is strictly symbolic. And you may notice that there are 3 statement components here, R, S, and T. So we have a pretty big truth table at our disposal in order to determine if this argument is valid or invalid. Okay, so let's go ahead and initialize our R, S, and T columns accordingly. Remember, whatever the first letter is, it's initialized all T's up top, F's down below, then TTFF, TTFF for the second letter, which in this case is S, and then lowercase t, not to be confused with uppercase t, which is value of true. That lowercase t has a TF, 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 TF initialization. Now, notice that the first premise, you got to write that yourself. R implies tilde S. Second premise is tilde S implies tilde T. Third premise is R. Conclusion statement is tilde T. So go ahead, and it might require some side work to put the first premise truth values for the entire conditional statement. Okay, you just want to have the final answers here and here, right? You don't want to have this process gummed up with all of your work shown. I don't think that's best. I think just having the final answers. So if you want to do the side work to figure that out, maybe press pause on the video. Otherwise, I'm just going to go ahead and show you here as the first premise, combination of truth values for that conditional statement. Here is the second premise. Here's the third premise, which is simply copy and pasting R, and then negating T is the conclusion. Okay. So once all of the analysis or all of the truth table filling out is done, now we can start the analysis, which go ahead and focus on I kind of gave it away there, sorry guys, the first, second, and third premise, and find all of the rows in which they are true at the same time. So you got to have a T here, a T here, and a T here. And it looks like there's only one case in which that happens. And check this out, that one case has a true conclusion. So that means that this argument is valid, okay? There was not, for this particular argument, more than one case in which all 3 premises were true. And in that one case, the conclusion happened to be true, so that makes the argument valid, okay? If there was a case in which there was true first premise, true second premise, true third premise, and then a false conclusion, that would have made the argument invalid, but that did not happen, so therefore this argument is valid. Okay, another example. Go ahead and turn the page, and I believe this will be our last example for this particular lecture video. And so, yes, we will have to translate it into its symbolic form, and this time, for this example, they gave us letters to use as a jumping off point for our symbolic representation. And then we will fill out the corresponding truth table, and that will help us determine if the argument is valid or invalid. Let's start by reading the argument together. If it is a blot, then it is not a clot. If it is a zlot, then it is a clot. It is not a blot, therefore it is not a zlot. Did everybody follow that? Did anybody read that and was like, oh yeah, that's either valid or invalid, just from reading it right away? Personally, I did not, so I'm going to go ahead and go through the process of translating it into its symbolic form using the symbols that are given to me and keywords and phrases. So here is the argument in symbolic form. So maybe it will just go back to these one at a time. The first statement is conditional, and there is use of a negation connective. So it translates accordingly, right? Using the little arrow, that's the arrow associated with conditional statements. The second premise is another conditional statement, and the antecedent is a new statement component, Z, but then the consequent is an already established statement component, clot, which is already C. Now it's not tilde C for the second premise. Everyone hopefully is following that because there's no negation keyword there. There was a negation keyword in the first consequent using clot, but not here. Okay. The third premise is a negated B, right? Because it is not a blot. So therefore, it is not a zlot, tilde Z. Cool. So let's go ahead and bust out our truth table. A lot of it's already structured for you, but please at this time, if you haven't already done so, add the true-false combinations associated with B, C, and Z are 3 statement components in alphabetical order from left to right, and initialize them in the standard way. Always the first column is T, 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 F, 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 F for a 3 statement component argument or a compound statement. There are 3 because we have 3 different letters, B, C, and Z, and that makes for 8 different rows in the truth table, because there are 8 different combinations of T's and F's. You always have 2 to the however many statement components power, 2 to the third power being 8. Okay, so hopefully that's a little bit of a review on why it's as big as it is. The first premise, go ahead and if you haven't done so already, write down that first premise in symbolic form. B implies tilde C. Second premise is Z implies C. The third premise is tilde B, and the conclusion is tilde Z. Now, again, side work to determine the truth value combinations for all 8 cases. Press pause if you want to do that on your own, but here are the answers. Here is the truth value combinations for the first premise, second premise, third premise, and conclusion. Having the truth table already filled all the way out, we are now ready to start the analysis. The analysis is circle all the rows, all premises and conclusion in which all 3 premises are true at the exact same time. There are 3 cases in which this happens. True, true, true for first, second, and third premise, okay? Now, take a look at their concluding truth values. Notice that there is one instance, right, in which the true, true, true premises have a false conclusion. It doesn't matter that this case exists or this case exists, in which we have true premises and a true conclusion. You are looking to see if, in this case, T, 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 F from left to right exists. If you have true premises and a false conclusion, the mere existence of it invalidates the argument. So therefore, in this example, this argument is invalid. That's all that I have for today. Here is the associated homework for this section. These are the exercises I want you to try from the textbook. EOO, just as a reminder, stands for every other odd. Now that you've been presented with all of the Exam 1 material, you will want to start preparing for the review session coming up. It's going to be in the next, what's the word I'm looking for? The next class period that we have after we cover 2.4. And we're going to have an entire class period dedicated to reviewing for Exam 1. And there's also going to be a quiz after that review session. Okay, so I will see you very soon. It's been my pleasure. Let me know if you have any questions about this the next time we meet for class. Thanks.